Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. So here is a problem of the day 4. In acute triangle ABC, BD, CE are altitudes. BF, CG are perpendicular to ED on FG, respectively. Prove EF equals to DG. See, we want to prove that EF equals to DG. So for this problem, we have two elegant methods. The first one is easier to think of because we already learned the many properties of the author center. So when we see that CE is the altitude, BD is the altitude, we know that this point, let's call it H, is a author center of triangle ABC. So let's connect AH and meet BC on point K. So we know that AK is also perpendicular to BC. So let's look at this figure for the angle CDG, right? This angle. It equals to angle ADE, right? It equals to this angle. And we know that because H is the author center of triangle ABC, so we know that AEHD are cyclic. So angle ADE equals to angle AHE. Right? And angle AHE equals to angle KHC. Because triangle HKC and triangle DGC are right triangle, that means triangle DGC is similar to triangle, DGC, right? HKC. Right? Similarly, for here, we have angle FEB equals to angle AED, which equals to angle AHD, which equals to angle BHK, which means triangle FE, or let's see, EFB is similar to triangle HKB, right? So from this one, the triangle DGC is similar to triangle HKC. We know that DG to HK, DG to HK equals to DC to HC, right? DG to HK equals to DC to HC. And from this one, we know that FE to HK equals to BE to BH, right? FE to HK equals to BE to BH. Now let's look at DC, because triangle EBH is similar to triangle EBH, right? DCH is similar to triangle DCH. So we know that DC to HC equals to EB to HB, right? That means DC to HC equals to EB to HB. So we know that DG to HK equals to FE to HK, which means DG equals to FE. Okay. That's the first solution of solving this one. Let's think about the second solution. Just look at the figure. Because CE, so we don't need to bring the auxiliary center in for the solution 2, okay? Just think about CE is perpendicular to AB. BD is perpendicular to AC. So we know that B, E, D, C are cyclic, right? Then we can find the, and because angle BEC equals to angle BDC equals to 90 degrees, that means the circumcircle of the, actually circumcenter of BEDC, quadrilateral BEDC, is the midpoint of BC, right? So let's find the midpoint. M is the midpoint of BC, that M is circumcenter of quadrilateral BEDC, right? Which means ME equals to MD. Right, then we can find the midpoint of ED. Right, we find the midpoint of ED here. We connect this midpoint, let's call it N. Because EM equals to MD, so MN is perpendicular to ED. And N is midpoint of ED, right? And think about these three lines. BF is in parallel with MC in parallel with CG, right? And BM equals to MC. That means FN equals to NG. Right, these are three parallel lines, and we know that BM equals to MC, that means FN equals to NG. So, FN equals to NG, EN equals to ND, then we know that FE equals to DG. Okay, that's the second solution. So for this problem, I think this is about 8th grade to 9th grade problem. So you don't really need to have the knowledge of the auxiliary center. You can still solve it, right? But with the knowledge of the auxiliary center, you can easily find the, I mean, you want to find the midpoint and figure out that EM equals to MD. I would say it's a more elegant, smarter way than the first solution, but it's not very straightforward as analysis, right? The first solution is more reliable. If you have practiced a lot of problems, then it's very natural to use the first solution. And it's more, I would say it's more safety when you in a real computation, okay? These are the two solutions for this problem. I hope you like this video. See you in next one. Thank you.